Hello everyone, welcome to the next lecture on numerical analysis. Today I will explain you how you can find the multiple roots with the help of modified Newton-Raphson method. Myself Dr. Harish Garg, you can follow my YouTube channel where you can find the playlist of numerical analysis and you can see the various lectures related to the multiple roots, system of the nonlinear equations and many other lectures in this playlist. What we have discussed so far, we have defined the multiple roots. The roots x is equal to xi is called as a multiple root with the multiplicity m when if the mth derivative of the function at the point xi is my non-zero, while all those previous derivatives at the point xi is my 0. For more detail about the multiple root, I recommended you can watch my this lecture available at my YouTube channel. Now, if I consider these three functions, then what is the roots of these equations? Clearly say the roots are my 1 and 3. In this case, the roots are my 1, 1 and 3. While in this third example, the roots are my 1, 1, 1 and 3. What is the meaning of the 1, 1? That means it's my repeated root, or you can say it has a multiplicity 2. This has a multiplicity 3. Now, if you draw the graph of these functions, you will see these are the functions. Now, clearly say the roots is my 1 and clearly say at this point, there is a at the point 1, that is at x equal to 1, the function change its behavior. While if you look about this case, at the point x is equal to 1, the function does not changes its sign. That means if you consider the function value at the point of 1 negative, function value at the point of the 1 positive, both have the same sign. That means if you say the sign of the function does not changes for the even number of the roots. What does it mean? If the sign of the function does not changes, then the bisection method as well as the regular falsy method is not applicable for this function to find the multiple roots. On the other hand, if you look about this case, because the function has a multiple roots, so that means f of x is my 0, f dash of x is also 0, and once the slope is my 0, what does it mean? That means the Newton-Raphson method and the secant method may diverge or converges very slowly. What is the significance of these two cases, of these two observations? That means the earlier method named as the bisection, regular falsy, secant, Newton-Raphson are failed to find the multiple roots. Now, in order to find the multiple roots, in case of the multiple roots, we need a modified method and we call as the modified Newton-Raphson method. So remember, this modified Newton-Raphson method is applicable only if you are interested to find the roots of the equation with the multiplicity m. So once you have the roots of the equations with the multiplicity m, then the iterative formula for the multiple root is my this case. Or I can also write this equation. If you closely look about this equation, I can write this equation as 1 over m f dash of xn. So what does it mean? That means this component, that is the denominator, will represents about my slope of the curve. That means 1 over m f dash is the slope of the straight line which passing through this point. Moreover, another observation that we can obtain from this case, if I consider m is equal to 1, that means the multiplicity is my 1. Multiplicity 1 means that the roots are my simple roots. Fine. For example, if I consider the function is x square minus 4x plus 3, then what is the root of this equation? So clearly say the roots are my 1 and 3. So clearly say 1 occurring 1 times, 3 occurring 1 times. That is called as the simple root. So once you consider m is 1, then this equation becomes my Newton-Raphson method. Also, the modified Newton-Raphson method is also called as the generalized Newton method or the modified Newton's formula. Once we know this modified formula, then how you can solve this problem? I categorize this problem into the three ones. First one, when multiplicity is known, that means the value of the m1 is known to you. Second case, when the multiplicity, that is the m, is my unknown to you. And the third case, when the initial approximation, that is x0, is given to you and it is near to the actual root of the function. For example, when the first case will happen, because we know already m, then we can use this formula. For example, if you look at that, the first one, find the double root. What is the meaning of that double root? Multiplicity is my 2. Second example is show that this has the double root. That means again m is equal to 2. That means m is my given to you. How you can solve this problem? Let's see first example. What is the meaning of that double root? That means m is equal to 2. Now since the multiplicity of the function is given to you, that means we can apply this Newton-Raphson method. So for that case, we need the function. So fx is already given to you. So can you find the f dash? Because we need the derivative of also. So what is the f dash of the x? That is my 3x square minus 2x minus 1. I can substitute both the values at this given point. So that will be my xn minus m. For the double root, m is my 2. Fx, so xn cube minus xn square minus xn plus 1 divided by 3 xn square minus 2xn minus 1. Now you can take the LCM. What will happen if you take the LCM? 3xn square minus 2xn minus 1. Now it will be the 3xn square, 3xn cube minus x cube. That will be my xn cube minus 2nx square plus 2nx square. That is a cancel out. Minus xn plus 2xn and minus of 2. So this is the calculation procedure. Now how you can solve that? For in order to apply the Newton-Raphson method, you need the initial guess. Fine. So how you can find the initial approximation? You can choose any value of the x naught. You may choose as a 0.6, you may choose as a 2.7, you may choose as a 3.9. That is on your choice. Fine. So let's say I can start with the x naught is 0.7. I can substitute the value of the x naught in this case. You will get the x1 is 0.7 cube plus 0.7 minus 2 divided by 3 into 0.7 square minus 2 into 0.7 minus 1. You can use your calculator and get the results. Now make sure in this case it is not given that up to how much decimal places you needed. So by default you always need to correct the answer up to the 3 decimal places. So once you needed the calculation up to the 3 decimal places, so you can do all those calculations up to the 5 decimal places. And once you will get the final answer, we can round off them. Fine. If somebody will ask you that calculate the result up to the 4 decimal places, then do all the calculation up to the 6 decimal places. So now you can write this answer up to the 5 decimal places. Now once I can find the value of x1, I can substitute the value of the x1 in this equation. Then it will be 0. Cube plus x1 minus 2 divided by sum. So once you found, you will get this answer. Now clearly say up to the 3 decimal places, the results are not same. Then we can find the value of the x3. I can substitute the value of the x2 in this equation. Again, you can use the calculator and get the answer as this one. Now clearly say up to the 3 decimal places, x2 and x3 are same up to the 3 decimal places. So your desired double root is my, you can round off them to the 3 decimal places is my 1. On the other hand, instead of taking as the initial guess as a 0.7 because it is not given to you, if you consider as a 2.7, then what will be my x1? If I substitute the value of the x naught in this equation, you will get the answer as up to the 5 decimal places. Now clearly say up to the 3 decimal places, they are not same. I can substitute the value of the x1 again in this equation. I will get the value of x2. Again, you can see up to the 3 decimal places, they are not same. I can substitute the value of the x2 in this equation. You will get the value of x3. And then again, you can see up to the 3 decimal places, they are not same. Then we can find the value of x4. Clearly say x3 and x4 are same up to the 3 decimal places. So your desired root is my again 1. This is the case 1. Second case, when the multiplicity of the function is not given, that means when m is my unknown. For example, you can see, find the equation for the equation this, find the root correct up to the 3 decimal places using the modified Newton's formula. That means you have to apply the modified Newton's method, but m is my unknown to you. Then you have to use this formula. In this case, initial point x naught is also given to you. But before I directly solve this problem, the question arises is how this formula came into the picture. We all know the Newton's Raphson method is my this case. Fine. Now since the multiplicity of the function is not given, so I have not used as a m. What I can do is I can simply choose the function of the u, which is my f xn divided by f dash of xn. I can consider this function is my u. Fine. Then I can apply the Newton-Raphson method on the ux instead of the f. What is the meaning of that? I can replace this f to be my u. Fine. So that is my this case. Now since u is already given to you, can you find the value of the u dash? What is the derivative of this? I can apply the product division rule. So that will be f dash into f dash minus f into f double dash. Fine. I can substitute the value of the u dash in this case, value of the u at this point. And then you can simplify this, you can take the LCM and you will get the same result. Now, you can see again in this case it is multiplicity of the function is not given to you. Fine. So that means your target is to apply this formula. But if you look about this formula, you need to be f dash and the second derivative also. So I can find the value of the fx. Fx is already given to you, x cube minus 7x square plus 16x minus 12. Can you find the first derivative? First derivative is my 3x square minus 14x plus 16. Can you find the second derivative? This is my 6x minus 14. Fine. Now you can see that we need all the results up to the 3 decimal places. That means you have to do all the calculations up to the 5 decimal places at least. Fine. Now what is the initial guess? So since at the point x naught is 1 is given to you, so I can start with the equations. So first equation is I can find the value of the fx, f dash x and f double dash x at the point 1. So let's start with this. At the point of the x naught, I can substitute this value. We will get f of x naught is minus 2, f dash is 5, f double dash is my minus 8. Therefore, what is the value of the x1? I can substitute this value. What is the x naught? X naught is 1. What is my fx? Minus of 2. Derivative is 5 divided by f dash square 25 minus of 2 minus of 8. Now you can do the calculation up to the 5 decimal places. You will get the answer as 2.1111. Now because the initial guess is 1, again you can see up to the 3 decimal places they are not same. Then we can apply the equation number 2. I can choose this x1 as a new point. Fine. Then I can find the value of the f. I can find the value of the f dash. I can find the value of f double dash at this x1 point. I can substitute the value of the x1 in these 3 equations. You will get the value of fx1, f dash and f double dash. Substitute all these values in this equation. You will get x2 is my x1 minus fx into f dash divided by this expression, and you will get the x2 is my this term. Clearly say up to the 3 decimal places the results are not same, then I can apply the equation number 3 at the point of x2. I can find again all these values at the point of x2, and hence I can compute the value of x3 by substituting in this equation. Clearly say up to the 3 decimal places they are not same, then we can apply the equation number 4 at the point of x3. We can compute these functions. Then what is the value of the x4? Again I can substitute all these values in this equation. You will get the answer as this. Clearly say up to the 3 decimal places the results are same, so therefore x3 is approximately same up to the 3 decimal places. So your result is my 2.000 up to the 3 decimal places. Now, third case, when the initial approximation x0 is near to the actual root. Fine, actual root is given to you. Then in that case, we will try to find the modified Newton's formula. And then instead of the m, I can take an m minus 1, m minus 2, and so on. And finally, based on this initial guess, I can find the new x1 by taking the average of these numbers. Fine. For example, you can see the equation has the double root. That means m is equal to 2 is given to you. Fine. Starting with the initial guess x 1.5, clearly say the 1.5 is near to the 2. Fine. So then you can apply this formula. Otherwise, you can also apply the case 1 rule. That means you can apply directly this formula, that is the xn minus m xn divided by f dash of xn. You may apply this formula also, but whenever the roots are near to this, try to opt this method. So look at that, m is given to you. Fine. Starting with the initial point x naught, so clearly say f is a double root, m is my 2. I can find the value of f, f dash, f double dash. Fine. Now I need to compute this formula, that's x, because m is my 2. Fine. So since m is my 2, if I substitute this value, 2 minus 2 is a 0. So I have to take only the first two cases, f upon f dash upon f double dash, and so on. Fine. So since for that case I need the double derivative, I can find that. So initial point is given to you as a 1.5. I can substitute this value in the initial points. I can find the value of, so what is the x naught is 1.5, m is my 2. What is the value of the f of x naught? I can substitute the value of the f of 1.5. Similarly, f dash, in this case you will get these results. Fine. Now since you can see that the results are near to this, we can see their existence of the double root. So what is my x1? I can take, because there are the two numbers, I can take average of these two observations. Fine. So if you compute the average, you will get the x1. This is the equation 1. Now we can repeat the same experiment at the point of the x1. Now again we will compute, now in this case x1 minus of this. So what is the x1 is 2.0449. M is again my 2. I can substitute the value of the f. I can substitute the value of the x1 in the function of the f. Similarly for the f dash and f double dash, you will get these two results. Now again you can see the roots are similar, so I can find the average of these two cases. Now clearly say up to the 3 decimal places x1 and x2 are not same, then I can perform the third equation as well. Again you can compute this value at the point of x2, you will get these two results. Fine. And you can see the average is my, again you can see up to the 3 decimal places the results are same. I can say x2 is equivalent to the x3 up to the 3 decimal places, so the desired root is my 2 is the right answer. Now find the multiplicity of the root for the function of this case. Fine. How you can check about the multiplicity? That is, you have to watch about my this lecture of the multiple roots. But anyhow, I will tell you. That means f of x is given. You can find the f dash. You can find the f double dash. You can find the f triple dash until you will get this number as a non-zero. If I get f dash is 0, f double dash is my non-zero, then you have to stop that. Fine. Now look at that. Because fx is given to be, root is my 1. Fine. F of 1 is my 0. Can you find the f dash of x? So it will be twice x minus 1 into ln x plus x minus 1 square over x. Fine. So can you calculate the value of the f dash of 1? 1 minus 1 0, 1 minus 1 0. So it's a 0. Then we have to compute the second derivative until you will get the non-zero number. What is the f double dash of x? Again you can apply the product rule into ln x plus twice of x minus 1 over x. Again, what is the rule of this? It's a twice of over x minus x minus 1 square over x square. Now you can see it will be the 4 times, so and so on. What is the value of the f double dash of the 1? This is my 0, this is 0, this is 0, and this is also 0. Then since the second derivative is also 0, I can find the third derivative. You can find the third derivative very easily, and you can see at the point of the 1, this term is 0, this term is also 0, only the 1 is my non-zero. So now the third derivative is my non-zero, so therefore multiplicity is my 3 as per the definition of this. So that means this function has my multiplicity 3. I already explained you in the lecture of the multiple roots how you can find the multiplicity. Now once you know the m is given to you, that means your target is to find this case. Initial point x naught is given to you as a 0.5, so I can start with the x naught, or you can substitute the value of the fx f dash. Clearly say x minus 1 is a common, it will be cancelled out, and then you can take the LCM. 2 ln x plus xn minus 1 over xn. You can take the LCM, you will get this expression. Now start with the initial approximation x naught. I can substitute the value of the x naught in this given formula. It will be my 2 into 0.5 ln of 0.5 and so on. Fine. Again you can see they are only asking you to perform the 3 iterations, but the decimal is not given to you, so by default you have to perform the decimal up to the 3. So that means you need to do the calculation up to the 5 decimal places. Now again substitute the value of the x1 again in this equation, you will get the x2 and x3 are here. Because you can see up to the 3 decimal places they are not same, then you can compute the x3. Clearly say up to the 3 decimal places the value of the x2 and x3 are same, hence the desired root is my x is 0.999. Fine. But in this example they are not talking about they are only asked to perform the 3 iterations. Look at the next example. I hope you can like, comment and share this video with your friends as well. If the function f of x is this, check whether f has a 0 of multiplicity 2. What is the target? That means your target at the point 0. Your target is to prove f of 0 is 0, f dash of 0 is 0, f double dash of 0 is my non-zero. Then only it has the multiplicity 2, the second derivative is non-zero. So let's start with this case. So clearly say what is the f of 0? 0. What is the f dash of x? E raised to power x minus 1. So clearly say f dash of 0 is my 0. What is the second derivative of the x? E raised to power x. And clearly say f double dash of 0 is my non-zero. So therefore it has the double root. Once it's a double root, that means m is equal to 2 known to us. So once it's a known to us, then we can apply the modified Newton's formula. Initial point is given to you. We have to do all the calculations because the 4 decimal places are given to you. Then your target is to do all the calculations up to the 6 decimal places. I can substitute the value of the fx. It is e raised to power xn minus 1 minus xn divided by e raised to power xn minus 1. You can take the LCM and then you will get this expression. Initial point x0 is equal to 1 is given to you. So let's start with the x naught. Substitute the value of the x naught in this expression, you will get x1. I can substitute the value of the x1 again in this expression, you will get the value of x2. Clearly say up to the 4 decimal places they are not same, then we can find the value of the x3. I can substitute the value of the x2 in this expression. You can use your calculator in your examinations. You will get these 4 results. Clearly say up to the 4 decimal places the results are same, therefore the desired result is my 0 is the right answer. Find the multiplicity of the root alpha is equal to 0 for this function. That means we have to find the value of the m so that when you compute the value of 0, it must be non-zero. Very simple. Firstly, we will check about what is f of 0. 0, 0 and 0. Can you find the first derivative of this? So sine derivative is my cos x plus 2x into cos x minus x square into sine x minus 2x minus 1. What is the value of the f dash of 0? This value is my 1, this value is my 0, this value is 0, and clearly say this number is also 0. Then you can find the second derivative. Fine. So you can easily do that. The second derivative is my this case. What is the second derivative at the point 0? 0. This is plus of 2. This is 0. This is 0 and minus of 2. Again 0. Then we can compute the third derivative. What is the value of the third derivative at the point 0? Minus 1, 0, 0, 0. So that is my minus 1, which is my non-zero. Now since the third derivative is my non-zero, so the multiplicity is my 3. Now once the multiplicity is my 3, that means m is equal to 3 known to us. But if you read the statement, they are asking you estimates the number of these steps. They are not asking you to solve the problem. Fine. Estimate the number of the steps which will converge to the 6 decimal places. Now once we know it's a modified Newton-Raphson method, fine, then the order of the convergence will be m minus 1 over m. Here m is my 3, fine, so therefore error will be my 2 by 3 of epsilon. Now given that, what is the initial approximation? X naught is my 1. What is my root? Root is my 0. So therefore, what is my error? Initial error, that is alpha minus x naught, that will be 1. Fine. Once it's a 1, I can write this expression is 2 by 3. What is the value of the epsilon n? 2 by 3 into epsilon of n minus 1. Similarly, I can write epsilon n minus 1 as a 2 by 3 epsilon n minus 2 and so on. So I can write this expression is 2 over 3 raised to power n into epsilon 0. So epsilon 0 is my 1. So this expression is 2 over 3 n. Fine. Now what is given to you? Your target is to find up to the 6 decimal places. So what will be my maximum error? We all know the maximum error is half 10 raised to power minus n, where n is my number of the decimal places. So n is my 6. So I can substitute the value of the error. Error is my 2 upon 3 into n is less than of half. Taking the logarithm on the both sides, and you can solve this expression by the calculator, you will get as the 35.78. Since we need a number of these steps which is always integer, so therefore we will get the 36 steps you are needed to get the required result as the 6 decimal places. Look at this another one. Show that this equation has a double root. What does it mean? Your target is to prove at the point 1 f of 1 is 0, f dash of 1 is my 0, and the second derivative is my non-zero. Then only it has a double roots. The function is given to you, so I think that is you can do it by own. You can find the first derivative, that's a non-zero, that's a 0, second derivative is my non-zero. Once you can find the derivative, you will get the double root. Now since m is equal to 2 is my known to us, then your target is to find the modified Newton-Raphson method by using this expression. Again, the decimal places are not given to you. That means you have to do the correct result up to the 3 decimal places. That means your calculation is computed up to the 5 decimal. I can substitute the value of the f and f dash, and you can take the LCM, or if you want to take the LCM, that is your choice. Otherwise you can use as such. Substitute the initial guess x naught in this expression, you will get the value of the x1. Again, I can substitute the value of the x1 in this expression, you will get the value of the x2. Clearly say up to the 3 decimal places or up to the 4 decimal places the results are not same, then we can compute the x3. Again, the results are not same. We can compute the x4, and once you can compute the x4 and x5, you can see the desired root is my 1. Look at this another one. The equation, this has the double root. That means m is equal to 2 is my given to you, and the root is my 1. This is given to you. Apply the Newton's-Raphson method with the initial point x naught is my 0.9 up to the 3 decimal places. That means your calculation will be up to the 5 decimal places. Now you can see that these values are very near to each other. Once they are near to each other, then we have to apply which rule? We have to apply this formula. Fine. So for that case, because m is my 2, so I have to use only 2 equations. For that, I need to compute the f dash, f double dash. I can substitute this value. This is 0.9. M is my 2. Value of the x naught, substitute in the function of the f dash, f double dash. Fine. I can take the average of the x1. We will get this expression. Clearly say up to the 3 decimal places they are not same. We can perform the equation number 2. Again, I can find this value by the Newton-Raphson method. That means substitute this value of the x1 in these 3 functions and substitute in these expressions. Fine. Then you can find the x2 as the average of these 2 terms. So you will get this term. Clearly say up to the 3 decimal places they are not same. We can perform the third equations. Then again we can substitute the value of the x2 in this expression. You will get the value of the f2 and f1. Take the average of the x2 and you can see up to the 3 decimal places the results are same. Therefore the desired root is my 1. Fine. I hope you can like and comment on this video as well. These 3 questions are exercise for you, and I hope you can see find the multiplicity. You have to find the value of the m, and then you have to apply the Newton-Raphson method, which is near to the 3.9. Find the double roots. In this case, m is equal to 2 is already given to you, and in this case show that the double root is my, so that means your target is to prove f double dash of 1 point is my non-zero, or you can apply the Newton-Raphson method, modified Newton-Raphson method for m is equal to 2 and find the values and see whether the roots up to the 4 decimal places is given as this one or not. Let me know in the comment box, are you able to solve these questions similarly in a simple manner or not? We will see the next lecture on the order of the convergence. Till then, you can share this video with your friends. You can like and comment on these efforts. Thank you very much, students, and don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.